Hello developers, hope you're enjoying my ZIG word count clone learn by doing series. So in the previous one we have implemented a couple of more switches. So let's see what else we can do. For example, the word count is capable of processing more than one file. So if I see, I'm just passing the same. As you can see, it was able to figure out the number of lines, number of words and number of bytes and displays the file name, and then it summed them all and then displayed as a total one. Okay, as you can see here. So in today's session, what we're gonna do is we're gonna extend our utility. If I, for example, if you try to run with the same setup or with same arguments, what you're gonna do is at most you're going to get the first output, so it's not able to total it up. So let's try to extend our utility in today's session, and then we can match the parity with the word count utility available in Linux, and along the way learn how we can refactor and reorganize our code base to make it more maintainable. Okay, so I wait. Let me launch my helix editor. So open it up. Where are you? Oh, there you go. You see. So in the previous one, just to get started, I shove everything in one file, but this is now how it is recommended. Okay, what we can do is let's refactor this and into its own structure. Okay, what we can do is we can just copy the stuff, okay, and yank it and refactor it. For example, I can create one more window, vertical one, and say new here. There you go, and paste the code in the new file. Okay, so the way ZIG organizes the files, the files in ZIGs are basically structures. Okay, so what I did, I copied all the fields of the file. Okay, the way it is I have defined like this into its own file. Okay, and then because it needs few references, so let's provide that references as well. So let's save it. Save it. Save. Save. Right. Okay, and let's write it to result.zig. Okay, there you go. Now it is our LSP, language server protocol, is showing the error message. So what we can do is we can save it. Let's help it provide the the references of the std.io writer. So standard practice is what we can do. Stud const equal to import if I can type strut. Okay, and then as you can see here, the structure should have been where is the structure? Yeah, so let's save it. Save, right, and format it. Okay, so it formatted nicely. What you can do is you can get rid of this structure. Okay, so let me select this, and okay, and then Now the program will, we need to import it. So we'll say const result equal to import, and we'll say result.sig. There you go. Okay, now this returns a type, as you can see, and the program is back to the way it should work. Okay. Result.sig. Okay, save it, and let me close this. Close window. Okay, save and quit. And then if you go back, right and quit, ZIG build, there you go. The program is working as expected, but we have organized nicely in its own structure. So let's go ahead and then refactor to let it support for the multiple arguments. What we're gonna do is we need few more structures to capture the files. So what I'm going to do is I'm going to, we need this. Okay, so yank it, and then go ahead and move it here with the first line. Okay, then format it. Okay, and then we can declare another structure to capture the files we need. Okay, so what we can do is, so we are going to extend to support multiple files, so we don't need this. So remove this, and then create one more structure, an array list to capture the files. Okay, so var files equal to is stud array list of const u8s. So those are the arguments, and initialize it with empty one. Okay, and make sure to discard it once it is done. So this is the beauty of ZIG. You can write a differ, because this will be dynamically allocated. So you can say file start deinit closer to where you are declaring. So pass the allocator, and voila, there you go. So I remove that, the first this file path variable, and instead we're gonna capture or accumulate in the files. Okay, so here what you can do is try files dot append. So this is the append. It may fail, so you need to pass an allocator and an item you are appending to. So pass an allocator, not that, allocator, and then item is arg. Okay, pass it along and just get rid of this, format it. Okay, now all the files will be accumulated here. So let me, the rest of the program will remain same. Then what we can do is, after accumulating the files, we are going to initialize the result. Okay, so we'll say var result. This is the final result we are going to display. Call it as, instead of result, call it as total. Total is a result. Okay, and since we know most of the flags have been initialized to the past arguments, like show byte, show var, show line, show max length. Okay, so we need to initialize those, and then the file name needs to be initialized to total. Okay, so show bytes equal to show bytes, this is what we capture. Show lines equal to show lines, show words equal to show words, show max length, show max length. Okay, and then the file name for the total will be total. Remember that how that utility what quantity displaying in case of total. So after initializing that, what we can do is we gonna refactor the way this if you analyze this code snippet. Okay, what it is doing, it is just going over the file passed. Okay, so what we can do is let's first get a handle to start out. That's our FD. You remember in the previous one we say by default any process, any operating system opens 3 file handles, 0 for stdin, 1 for start out, and the third one is std error 2. Okay, so let's open std out because we're gonna write. So we'll say std fs file, okay, and std out, and then get hold of a writer, and the writer need to be pass a buffer. We want to make sure the moment we write it should be flushed automatically. So just going to initialize with a 0 bytes or 0 slice buffer. If you want a buffered capability, you can initialize to buffer like we did for the reading. But in that case, what's gonna happen is you want to make sure like the final statement is the flush, because until you do that there will be few bytes will be accumulated. But if you initialize with the 0 bytes buffer, doesn't matter, the moment you write automatically it will be flushed out. Okay, so remember that point. Okay, so we got hold of to a writer. So what we can going to this, let's loop over the files. So we'll first check if files dot items dot length equals to 0. So what does it mean? It means the file argument is not passed. So probably no, we need to read from the stdin. Okay, so we are just going to initialize. No, just we are going to refactor this code also. So first let's refactor the code. I am going to just select this, select, keep going, good, keep going, and then yank it. Okay, and I can remove it. Okay, and let's refactor this into another function, fn process file. Okay, now process file going to take few parameters and it is going to return a result object. Okay, in fact you can just keep its own file, but for the sake of simplicity I'm just refactoring within the main file, main.zig, but it's up to you also. Okay, so let me paste it. So there you go, what parameters are needed. So definitely it needs to pass a file this variable show bytes. So let's do that, and it needs to capture the words also. So an allocator is also needed. So let's start passing the parameter allocator is start mem allocator. Okay, then I'm just using I'm just individually specifying the parameter on separate line. So show bytes is a type boolean. Okay, and show words will be of type boolean. Show lines will be of type boolean. Show max length will be of type boolean. And then the final, last but not least, is file path. The file path is a nullable string const u8. Okay, then it is checking the code, more or less, remain the same. So we're gonna declare a variable buffer, okay, and we are going to open a file. If file path is passed, try to open that. If not found, try to error out the reason why it cannot open it and exit the utility, or otherwise if it is null, it means it's going to come to the else block. Then we have to read from the stdin, the user is going to input, okay. Then we are the other remains same. We are since this method is returning a result, we initialize the result. Then afterwards we are doing whatever the we are creating a buffer reader with 1 KB of buffer and processing the bytes. Our business logic is there, and finally we accumulate the result, and let's return the result. Return result, okay. And this is the end of the method, okay. So now we refactored into its own method. So let's get rid of this. We can just remove this. So go to the visual mode, selection mode, remove, and then delete it, okay. So now what we are going to do is we are going to loop over all the files, okay. If the file items is length is 0, it means, what does it mean? It means we invoke we are going to invoke process file. It takes an allocator, okay, then show bytes, then show words. This is what we have refactored to. Show lines, then show max length, then last but not least, the file path. The logic we have written is it has to be a null one, okay, and you can get rid of the other one. So get rid of the other one. Other parameter, you can just if you leave the comma as a parameter, then LSP will nicely format it, okay. So this may return into a result. So I am going to just, because it's a fallable one, I will just say try, okay. Then what we're gonna do is, after getting the results back, we are going to display the results. So say try result dot format, or old method, helper method to format, and let's parse the stud out variable, if you hope you remember that, and writer, oh sorry, not writer, interface, okay. Let me format it. Now it's much better. But what will happen if it has files passed, okay. So now we have to write a else block, and we have to loop over every file pass. So for files dot items, okay, and we call it as path, file path, okay. So this is a for loop. So you can loop over an iterable, so that iterable value will be plug into this variable capture of between these two pipes, and we gonna do the same thing. Try process file and pass an allocator, okay. After allocator is passed, what we're gonna do is we're gonna pass the rest of the parameters. Show bytes, okay, then show words, then show lines, okay, then show max length, then the actual path. The path is it's in path variable. Let's pass it that, and give one extra comma, just so you get an extra help from LSP to format it nicely. Then what we can do is we gonna display the result. try result dot format. It needs a writer, so writer is stud out and stud out, a pointer stud out and interface. That's our writer. And then what is next? So this logic we have written so that we should display the total results. Remember here our total, there we are capturing the accumulating all the bytes. So we have to accumulate the results. Accumulate, okay, accumulate the totals. So what we're gonna do is total dot total bytes plus equal to result dot total bytes. Okay, total dot total lines plus equal to result dot total lines. Total dot total words plus equal to result dot total words. Okay, and total dot max length equal to should be the max one. So let's use the built-in max total dot max length or result dot max length. Okay, then what we're gonna do? We are done with all the files. Then what we are going to do is, if condition is if the file path is is the file items, not this file dot items dot length is more than 1. Okay, then we are going to display the result for the total structure. The format start out. Oh, I keep forgetting. So I need to take the address and interface. Okay, looks promising. So let's give it a try. Do we need this? No, we don't need this. So let's get rid of this. Okay, and save and quit. Give the ZIG build it. Oh, no errors. Voila. So let's run it. ZIG build run, pass the parameter. So it should display. Oh my god, we need a new line definitely. So let's do that. Let's add a new line here. So we can go to this and introduce a new line at the last one. Okay, try writer dot print and new line, and you need to pass an empty tuple. Okay, format, save and quit, ZIG build, pass the parameter. Oh, there you go, as expected. Now ZIG build run and pass 2 files. Let's compare it with our word utility, word count utility. Okay, matching 24, 25 and 20. There you go, total, it's matching. Okay, and how about we don't pass any parameter, or then what will happen? It's reading from the here. A quick brown fox jumps over a lazy dog. Some new line. Hint the operating system by pressing Ctrl D. There you go. It is reading. If you don't pass the file's parameters, it is using from the stdin. So that's all I got. I hope you enjoyed doing completing this utility, word count utility, along with me. So we have extended, in the nutshell, in summary, we have refactored the result structure into its own file, and we extended our utility so that it can honor more than one input file. Hope you enjoy this ZIG session. If you like my content, uh, don't forget to hit like, share, and subscribe to my channel. So until then, keep practicing and keep building your ZIG skill. Okay. I think this is last but one. I intend to parallelize this so that instead of uh, processing the file one after the other, we can just use um, an executor or threading capability and just submit the files in the to the operating, because most of our operating systems or hardware having multi-cores, so we can let multi-core process each file individually and we can save time. Okay, all right, until then, keep practicing. Bye for now.